Welcome to the Project Management Prepcast, your guide to PMP exam success. Here's your instructor, Cornelius Fichtner.
Hello and welcome back to part 3 of the Project Management Prepcast's lesson on Develop Schedule. I'm your instructor, Cornelius Fichtner. So in part 1 we saw the overview and the inputs. In part 2 we looked at the first few of our tools and techniques, which we are now here in part 3 going to complete. And then, just looking ahead, of course, in part 4 we'll be doing the outputs and a review. Alright, so when it comes to the tools and techniques, we've already reviewed the first 3 in the last part: schedule network analysis, critical path method, and critical chain method. But right now, here in part 3, we are going to concentrate on resource optimization techniques, modeling techniques, leads and lags, schedule compression, as well as the scheduling tool. Resource optimization techniques are those methods that match scheduling activities with available resources to achieve project goals. There are 2 types of resource optimization techniques here that we need to be talking about. First of all, resource leveling. It considers available resources and project time, as well as reviewing scheduling activities and required resources. And then resource smoothing creates an updated project schedule by analyzing schedule data using schedule network analysis method. Okay, let's look at each of these 2 techniques in more detail, beginning with resource leveling, shall we? To begin, let me ask you this question. Have you ever played the game of Tetris? It's a very simple yet addictive concept. You have shapes falling from the top of your screen and you rotate those shapes so that they fit into the openings that you have at the bottom of the screen. If you are very good, you can fill complete columns all the way up from top to bottom, and if you're very bad, the shapes, they start piling up and your screen becomes just a mountain of blocks and the game ends and you lose. Resource leveling is actually a lot like Tetris. It involves adjusting schedule network activity start dates and finish dates based on project resource constraints. The goal is to balance the demand for resources with the available supply of those resources. Resource leveling can be used when shared or critical resources are only available at certain times or in limited quantities or are over-allocated. An example would be if you have the same resource assigned to 2 or more activities during the same time period. Resource leveling can often cause the original critical path to change, most often to actually increase it in length. The 2 main reasons why you may want to use resource leveling on your project is because you either have your resources over-allocated or you have them under-allocated. So as you perform your resource leveling, you will find over-allocation of resources. This might be because we scheduled certain activities that require the same resource simultaneously, and a single resource, of course, can only work on one activity at a time. If you have an over-allocation on one of your critical activities, you are probably going to reallocate resources from one of your non-critical activities, or you can employ technology in support of the over-allocated resource. A simple example is if you need to dig a hole and you don't have enough resources to do that, well, go ahead and rent an excavator to help dig the hole, which will be both faster and more productive. And you will then also find under-allocation of resources on your project. For example, sometimes you may notice people sitting around waiting because nothing is assigned to them on a particular day. Now you have these resources under-allocated, so you need to reassign them to other activities. In both cases, under-allocation and over-allocation, you are going to want to make changes to the schedule. Resource smoothing, on the other hand, is a resource optimization technique that adjusts the activities of a schedule model so that the requirements for resources on the project do not exceed certain predefined resource limits. The name smoothing comes from our attempt to determine a resource requirement that is smooth and where peaks and valleys are eliminated when using this resource throughout the project. For example, even if you have 7 units of a given resource available all the time, using 5 of these units each week, 5, 5, 5, 5, is much preferable to having 4 in the first week, then 7 in the second week, then 2 in the third week, and then 7 again in the last week. Even if there is no limit to the amount of any one resource available, it's still desirable that resource usage is smooth as possible throughout the entire course of your project. When using resource smoothing as opposed to resource leveling, the project's critical path is not changed, and the completion date is also not delayed. This means that when you use resource smoothing, the schedule network activities may only be delayed within their total float and their free float, and because of this, not all resources may be optimized using this technique. Remember, resource smoothing helps keep resource usage at a constant and consistent level throughout the project. Let's finish these two techniques by looking at the differences. When using resource leveling, the schedule network start dates and finish dates are adjusted with the goal of balancing the demand for project resources and the supply or availability of project resources, and this can often cause a change to occur in your critical path. On the other hand, when using the resource smoothing technique, the schedule network activities are also adjusted, but with the goal of not exceeding predefined project resource limits, and may not optimize all project resources, and the critical path will not be changed. The two modeling techniques that we're going to need to look at are the what-if scenario analysis, which involves evaluating scenarios to determine their effect on the project, and simulation, using the Monte Carlo analysis, which involves calculating multiple project durations. Modeling techniques are used to review different sequenced events or scenarios, guided by risk monitoring, to bring the schedule model back into alignment with the project management plan and the approved schedule baseline. So the what-if scenario analysis is the process of evaluating scenarios in order to predict their effect, positive or negative, on your project. A schedule network analysis is performed to compute the different scenarios. The outcome of performing this scenario can often be used to assess the feasibility of the project schedule under different conditions. This technique can also be used to prepare contingency and response plans to overcome or mitigate the impact of unexpected situations on the project. How about an example? Let's say that your project is being executed in Canada, but your supplier is located in Sri Lanka, and you want to look at different what-if scenarios. So, first, you open up your project schedule in your scheduling tool to look at different scenarios, and you ask yourself, what if our supplier in Sri Lanka is 3 weeks late? What if there is a strike in the French ports and our shipment gets delayed by a month? Or what if the technology turns out to be more challenging than we thought and the design phase takes 6 weeks longer than anticipated? So you enter the data from these different scenarios into your scheduling tool and you run them to determine the effect that they would have on the schedule if they actually occurred. These what-if scenarios are at the heart of what you do in this tool and technique. However, this is very slow and very time-consuming. The problem is that when you do this manually, you can only do one single what-if scenario at a time. But what if you could do thousands at a time, simulate trends, and take all possible scenarios and risks into consideration? What you would have is a simulation called the Monte Carlo analysis, which is our next tool and technique. Simulation involves calculating multiple project durations with different sets of activity assumptions. It normally includes the use of probability distributions that are constructed using 3-point PERT estimates to account for uncertainty. The distribution of possible activity durations is defined for each activity and used to calculate a distribution of possible outcomes for the entire project. The most popular form of this is the Monte Carlo analysis. How about an example of simulation using the Monte Carlo analysis? Monte Carlo analysis models and simulates your project many thousands of times using a software application. Cost estimates and activity duration ranges are entered into the simulation and chosen at random by the software to develop different possible outputs based on the inputs. Say you have 100 activities in your schedule, and each activity can be up to 10 days early and up to 15 days late. It would be impossible to do a manual what-if scenario with all the variations here. You want this to be automatically calculated, and that is where you will use the Monte Carlo analysis. By the way, the method is named after the city of Monte Carlo in the Principality of Monaco because of roulette, which can be considered to be a simple random number generator. The name and the systematic development of Monte Carlo methods dates from about 1944, but you don't have to know this for the PMP exam. Anyway, what you have to remember, however, is that we have hundreds and thousands of what-if scenarios, and we are going to use the Monte Carlo analysis to calculate them automatically. We first met and discussed leads and lags in the sequence activity process, and we're going to be using them here again. But while we want to apply leads and lags at this point to create a viable schedule, you also have to remember not to just do this blindly. So do keep the following in mind here. In sequence activities, we originally defined these leads and lags to help with the original sequencing. But in the meantime, we went through the processes of estimate activity resources and estimate activity durations, and we may have applied quite a few changes to the schedule as well as added constraints and assumptions. It is quite possible that these original leads and lags are now no longer valid and that they may need to be adjusted at this point here. Schedule compression techniques are next, but before we look at these different techniques, what do we mean by schedule compression? The PMBOK guide defines schedule compression as techniques used to shorten the schedule duration without reducing the project scope. This means that talking to the sponsor to get a schedule extension and discussing the removal of features with the users, those are not schedule compression techniques. There are two types of schedule compression techniques that we need to look at in detail. They are crashing, which involves shortening the schedule duration, and fast tracking, where activities that are normally done in sequence are now performed in parallel. So why would you need to use schedule compression techniques on your project? Well, as the definition stated, you would use them to shorten the schedule duration without reducing the project scope in order to meet schedule constraints, imposed dates, or other schedule objectives. Let's take a look at the details here. Crashing is a schedule compression technique used to shorten the schedule duration for the least incremental cost by adding resources to your project. Crashing only works for those activities that are on the critical path of your project schedule, where additional resources will shorten the activity's duration and therefore shorten the critical path and therefore shorten your project. Crashing does not always produce a viable alternative and almost always results in increased cost. Examples of crashing include approving overtime, bringing in additional resources, and paying to expedite delivery of activities on the critical path. Here's an example. Let's assume that you look at your schedule and you see that you don't have enough time to finish the activities. You have 10 weeks of work left on your project, but you have promised to the customer that you will complete the project in 8 weeks from now. So you obviously have a problem. Your response as a project manager is to take these 10 weeks of effort and compress them into 8 weeks of actual time in the calendar. So let's start out by adding more resources to the project. This technique is called crashing. The idea here is to look at your schedule activities and figure out to which activities you can actually add resources in order to get the most schedule reduction. But you only crash those activities that are on the critical path. Why? Well, there is no point at all to crash an activity that is not on the critical path. In our example here, the effort of our project is 10 weeks. That is our critical path. There are always activities that are outside of those 10 weeks, that are done in parallel, not part of this 10-week path. And even if we were able to shorten all the activities outside of these 10 weeks down to just 1 hour of work, well, we have not shortened our 10 weeks at all. So only crash activities on your critical path. Second, we have to take the crashing cost into consideration as well. Let's assume that you have 2 activities that you could crash. Activity A will cost you 200 euros and you can crash it by 3 days. You can shorten it by 3 days. Activity B, on the other hand, costs you 500 euros and you can also crash it by 3 days. Which one would you choose? Well, the answer is simple. You choose the cheaper one, of course. So remember, when answering exam sample questions, that you always crash those activities that are cheapest or bring the most reduction at the same price first. Fast tracking is our second schedule compression technique, in which project activities or project phases that are normally performed sequentially are now performed in parallel for at least a portion of their duration. Fast tracking may result in rework and also increases project risk. Fast tracking only works if activities can be overlapped to shorten the overall project duration. An example of fast tracking is that you start the construction of the house foundation before completing all of the architectural design drawings. By way of example here, let's continue our crashing scenario. Let's say that we have crashed the schedule and we were able to reduce our 10 weeks down to 9 weeks. So it's still 1 week too long. We have to get it down to 8 weeks. It looks like we have to be a little bit more creative now. So let's try our next schedule compression technique, which is fast tracking. In fast tracking, we are going to overlap project activities that normally don't overlap. So let's say that the first 3 weeks of our schedule are pure design, followed by 2 weeks of prototype development. Now, this is going to be risky, but after about 2.5 weeks of design, we can probably start working on the prototype and continue to finish the design in parallel. And in this fashion, we will go through all the schedule activities in our completed schedule to decide if we can risk starting them earlier than we had originally planned and run them in parallel. By the way, do you remember the float that we discussed earlier, and I mentioned that float can also be negative? Well, that is exactly what we are doing now. We are giving a negative float to these activities so that they start before their predecessors finish in order to meet our overall project target finish date. And here are a few additional facts that you should remember about our two schedule compression techniques of fast tracking and crashing. First of all, there is no reason to fast track or crash any activities that are not on the critical path, because you will not gain any time whatsoever on your overall schedule if you cannot shorten your critical path. Crashing is costly because we are adding resources to our project. I don't think that there is any doubt in your mind about the fact that if you add more resources to an activity, it's going to cost you more. Fast tracking is risky and may lead to rework on your project. Let's assume that we fast track the production of the prototype and then the designers change the basic design. That will lead to rework because we'll have to redo the prototype again, and we may lose even more time. In the end, you must decide if you are willing to make the trade-off between having this increased risk or cost and being able to implement a shorter project schedule. Our last tool and technique here in Develop Schedule is the scheduling tool. And this tool may sound familiar because in part 1 of the lesson I talked about the need for taking all of the data from the inputs of the process and entering it into the scheduling tool. Well, we have now come full circle to this tool. Automated scheduling tools are software applications that contain the schedule model and expedite the scheduling processes by automatically generating start and finish dates based on the inputs of activities, network diagrams, resources, and activity durations using schedule network analysis. A scheduling tool can be used in conjunction with other project management software as well as with manual methods to create an updated project schedule. But frankly, why do it manually when you can use an automated scheduling tool? And with that, we have come to the end of part 3 of this lesson. So it's time for Justine to say,
keep it up.
And it's until next time from me.